Góðan daginn allir, velkomin á þennan fyrirlestur hérna hjá henni Deepthi Goguri. Já. Hún sem sagt SQL administrator og sem sagt Microsoft Data Platform MVP. Hún sem sagt með heimasíðu sem heitir dbanuggets.com sem hún að blogga og einnig mjög innvinkluð í Redgate, sem sagt vinur Redgate, she's a friend of Redgate, eins og við segja. Og hún einnig sem sagt organizer eða co-organizer fyrir Microsoft Data and AI í South Florida og í alls konar svona virtual groups, einnig fyrir sem sagt data volunteer fyrir sem sagt sérstaklega fyrir konur í tækni, women in technology. Þannig að hún elskar alls konar arts and crafts. So Deepthi, welcome. I'll give you the torch now and thank you for coming and helping us with this.
Sure. Give me a minute. I'm trying to share my screen.
Yeah, you can see your screen.
Okay. Are you able to see the screen now?
Yep.
Can I go ahead and get started?
Yes, go ahead.
Awesome. Thank you, Gisli, for giving me this opportunity to present at your group. I know it was a last minute and audience might be confused by looking at the title of the session because my friend who was the actual presenter, his name is Kai Sauter, he was not available, and due to emergencies, I had to jump in to cover up the session for him. So I hope you will like this session. So basically an introduction to like what I'm going to talk today was about the performance, like what are the performance tools that are available in Azure. Like this is not like a 300 level session, but if you're getting started in Azure or if you're already working in Azure, I think this session will be a good overview of what tools you have and how you can take the leverage and use those tools for your advantage. So I hope you'll like it. So let's get started. Myself, I'm Deepthi Goguri. I'm a database administrator since like about having 8 years of experience as a DBA. I'm a data platform MVP and I also co-organizer for a couple of user groups. I'm a co-organizer for diversity, equity, inclusion user group and Microsoft Data and AI South Florida user group. I also do volunteer for Women in Technology user group as well. And apart from my community work and my job, I love doing arts and crafts. So that's about me. And if you would like to contact me later, if you have any questions or if you'd like to know what I'm going to speak in the next sessions, you can contact me on Twitter at dbanuggets. And I have my own blog, dbanuggets.com, where I mostly write about SQL Server and Azure. So if you'd like to see more of those, please visit my website as well. And I'm very active on LinkedIn. So if you want to get in touch with me, please type by name Deepthi Goguri, you'll find me. So when we say that it is like our databases are performing well or our application is performing well, when the queries from the application, when they do those clicks and when they do those actions on the website, everything seems to be fine. If the results are, they can retrieve the results very quickly. That's when they say like, yeah, performance is good from the website. But if something happens, like if for any sort of reasons, if it is database reason or any other network reason, if they couldn't retrieve the results properly, then that's when they say like the website itself is down, right? But it might be database performance issue or it might be some other issue. But when do our queries run fine? like within the SQL Server, if you run your queries, there might be the several factors like it might be the CPU, memory, IO factor, or the query itself might have the developers might not have written the query well, so they need to rewrite the queries to make it the better performance. So when do they say it's a slow performance? Like users are actually, you'll get the calls to the service desk saying the website is totally down, right? You'll get the panic mode of like, but then until you dig to the actual problem, you do not know where the problem is caused. It might be anywhere. It might be like network, or it might be the drive issue. It might be the um, server might be really busy. It can be anything. So what factors, like when you are building a database, let's say, what factors are really important to so that your database can perform better, right? um, the most important things that we need to consider are the capabilities, like performance capabilities, like what are the maximum capacities that you are choosing to the database, like what is a CPU, memory, IO, those sort of capabilities, what are the maximum capacities that you are setting for the database, and whether you are using indexes, especially for the SQL Server database. Are you having those indexes to retrieve? Indexes are used to retrieve the results. Those are used for the read-only operations. So whether those are fixed properly, those are created properly, and whether they are being used by the optimizer properly. Those things are important when you are building the queries, making sure you create the indexes properly. And if you are in the business, if you are choosing the business critical database, then you have in memory OLTP options in Azure. Um, so you need to make sure like which capacities have the ability to choose in memory OLTP. It's only option in business critical databases. And mostly importantly, in this session, we are going to focus on the intelligent performance. So we have certain intelligent performance features in Azure, like for example, query store. Query store, how do you take the advantage of automatic plan correction in Azure, which is automatically enabled? And how do you do the automated task when you do not have SQL Server agent with the Azure SQL database? We are going to talk about that. I'm not going to talk in depth about this slide, but as an overview, like we have general purpose, business critical, and hyperscale models in Azure. And left side your screen, you can see the service tier, purpose, compute, storage. All these things that I mentioned here are what are the capabilities that you can choose and what are the maximum capacities that you can have in each of these model that you choose. So, like I said, like while you are building the database, Azure SQL database especially, um, what factors are really important? There are a couple of things that we need to consider. Like for example, the tempdb. So in Azure, the tempdb is always stored uh, in the local SSDs. It's always stored in the local SSDs, and you can choose the size and the number of files that you want for your tempdb, but you cannot choose the location where it is actually stored. So you will not have the view of where it is actually stored. And for the Azure SQL database, the maximum number of files that you can choose for the tempdb is 16 files. And for the managed instance, you can choose 12 files. When we talk about the database configuration, right? There are like when you build a database, it is always going to be in the full recovery model. You cannot change that because of the service level agreements taken care by Microsoft. So it has to be always available. The max DOP settings, right? Especially used in query hints. Like we are going to talk about query store in this session. So there are a couple of query hints that you can use by taking the advantage of query store. So what these hints can do is like you do not have to change any code, like for example the store procedure or anything. You do not have to change anything the underneath code for your store procedure or for your queries, but instead take the advantage of the query hint store procedure that is especially designed for the query store, and use the hints like for example the max stop settings, um, and like those sort of settings you can use especially for that query without touching the code, because we have the query hint store procedures available in Azure. They are also available in on-prem, but we are talking about the Azure in this session. So um, alter database scoped configuration can also be used. When we talk about the files and the file groups, um, adding the files and the changing the file sizes, you can choose, but where you are storing those files cannot be chosen, like the tempdb. So let's talk about the indexes a little bit, right? As an overview, like when you are building your queries, you need to create those indexes for the retrieval of your data, right? For the select processes. But why, like, how do we maintain these? It's not like creating the indexes and forgetting about them, but we need to maintain those indexes. Indexes are basically, they use like when the SQL server, you run your queries, it will use the optimizer to go ahead and see the statistics, like what are the statistics information. So basically, what are these statistics? As an overview, these are like the table structures built within the database in the system, at the system level, right? These are like the system views that are built within the database, and they show like the flow of your data, how the data is distributed within your database. So basically, like when your queries are run for the first time, let's say, the optimizer will first go ahead and look into the statistics. It won't go anywhere. It will directly go and see at the statistics. It will go ahead and see how is the flow, and for like what is the flow of the data within your database and what it is asking you to retrieve. And based upon those results, the statistics results, it will go ahead and allocate the options like how much of CPU memory should I allocate for this query to be executed. Even before execution, the resources, the amount of resources that are used to run the query are allocated totally based upon these statistics. And if you cannot maintain these statistics, what can happen is like, for example, let's say we have a stale statistics and we are not maintaining them. For example, if you are running a query which will give 50 rows, let's say, as a result, but then your stale statistics is saying 1 million rows. Let's say you initially had 1 million rows for that result, but then other operations happened and you deleted the rows, you modified the rows, and now you can get only 50 rows. But because of these statistics are stale, it will allocate the number of resources for those 1 million rows instead of the 50 rows. Now imagine while running the query, it only needs couple of resources and it doesn't need the resources for that million rows to be retrieved. So what happens, like your resources will be wasted, other processes and other queries will be waiting for the resources, and until this process is completed, the resources are not released. So that is the reason why it is very important to maintain the statistics. And after maintaining the statistics, we need to also maintain the indexes. So what is the combination? Like what is a combination between these statistics and indexes? Whenever you are rebuilding your indexes, like if your indexes are like fragmented, then you need to rebuild the indexes. That is one of the maintenance operation. Whenever you rebuild the indexes, your statistics will be also rebuilt. So that means like we can say that your statistics will always be refreshed whenever you rebuild the indexes, and that doesn't happen when you reorganize the indexes. So when you try to reorganize the indexes based upon the fragmentation levels, let's say the standards say that if the fragmentation is above 70%, then go ahead and rebuild your indexes. In that case, your statistics will be automatically rebuilt. But if you're reorganizing, if your fragmentation levels are less than 30%, then you will say like just go ahead and reorganize the indexes, but not touch the statistics, because reorganizing doesn't touch the statistics at all. So you need to make sure the balance between both of them is good. You need to make sure these are in place. The automated maintenance of these indexes and statistics are in place. But what do you do when you have Azure SQL database? Because you do not have SQL agent, which will take care of automated jobs. It's not available. So how do you take care of these in Azure? So maintaining the statistics and indexes in especially in Azure SQL database can be done by using Azure automation, and you can also create the Elastic agent jobs. So let's go ahead and see how to basically create one of these automation job to maintain the indexes, let's say. But uh, as a prerequisites to build this automation job, we need couple of things. Like because we are building the automated job for maintaining the indexes and statistics, there are free scripts out there. In if you search Ola Hellengren scripts in Google, you'll find a free scripts where you can go ahead and take advantage of to maintain your automated tasks for your database. So go ahead and download those scripts. It will give you a single script where you need to download and execute in your environment, which will go ahead and create couple of store procedures in your database. So once you're done with that, the next step is to create the automation account. Once you create the automation account, you need to download the SQL Server module from the marketplace, from the Azure marketplace. And then after that, you need to create a credential which will be used to run that automation job. And finally, you will be creating a runbook where you can um, write your script, a PowerShell script, which can run that particular Ola Hellengren script, and you can actually schedule the job. Now let's go ahead and see. I have downloaded the Ola Hellengren scripts and I have it executed in my management studio by connecting to the Azure SQL database. So if you see here, it has actually created a couple of store procedures: Azure SQL maintenance, database backup, database integrity checks, index optimize. That actually like Ola Hellengren scripts, it will take care of total maintenance of the database, like backups and optimization, integrity check of your database. If your database is corrupted, it will give the alert, like it will throw an error, sort of things. Like it's a complete package for free. So you will be seeing those store procedures. Now next we are going to create the automation account. So I'm not going to show you like every step like how to create it, because it is very simple. Once you open up the portal.azure.com, search by automation account, all it will ask you is the name, your subscription details, a resource group where you want to create this resource, and then which region you want to create, and then and then like network connectivity and those sort of things. Click on create. It will create the automation account, and the next thing is to download the SQL Server module from the marketplace. Again, you can go ahead and search for the SQL Server module. Just like the way you download any other tool, you need to click couple of clicks and you can download that SQL Server module. And you can find that SQL Server module under your automation account. So under the automation account, if you see the shared resources on left side your screen, it shows modules. So once you click on that, that module is available. And later you need to create the credential. Like I said, I gave my own username and password to create the credential, which is also shown in the automation account under the shared resources. Under the credentials, you see a credential. And then now I'll create the runbook. So underneath the automation account, again, go to the process automation left side your screen, and it shows as a runbook. So we are going to create a runbook to run our automation job. So once I click on that, sorry, I think I need to put this slide ahead of time because before running the runbook, we need to also create the variables because I don't want to hard code my values. I want to make sure like I use the variables. So um, again, underneath the automation account, you need to go to the shared resources where you have variables. So here I'm going to use two variables here, two strings, database as well as SQL Server, and I will give the values Adventure Works as a value, and then the SQL Server a database like uh, my logical server name to connect to the database. I'll give that server name, and then I will create the runbook which will have the PowerShell script in it. And like we did, like we need to provide the credential over here, and then automation like what SQL Server, like SQL Server variable and database variable. And all that it is doing, last line, if you see the last line in the query, it is going ahead and running that execute Azure SQL maintenance store procedure. And by giving the operation all, meaning like go ahead and take care of all the operations, like we showed, like um, and then and it is also logging to the table and providing all the like the query timeout and other things. And then once you are done with that script, once you create the runbook, you can go ahead and either schedule that runbook, or you can also go ahead and run it immediately as you want. But I'm going to schedule it here every Saturday recurring, and you can provide the timings and then click on create. So here, as an example, in my database, I have I did so many operations like the in like selects, inserts, updates. So whenever you do the inserts and updates, not only the changes happens in the tables, but also those details needs to also be updated in the indexes, because indexes are nothing but the collection of your column data. Like for example, if you create an index on the column in your table, then it will go ahead and save all the column data in that index. So whenever you are inserting some data into the table, it should also insert that values for that particular column into the index as well. So that will cause a lot of fragmentation because the data will be moved here and there within the index. It's internally done. So as you do a lot of operation, you can cause the fragmentation. So let's see, like the first picture, it will show you the fragmentation percentage. The last column will actually show you the index name and then average fragmentation in percent. So the last two indexes has actually 99.99 fragmentation because I did lot of activity. So when was my indexes lastly updated? I have executed a query. It was never updated because I just created my demo and then I did lot of operations and it was never updated. So what I will do is I'll go ahead and manually run that particular runbook. So once you create the runbook, you can actually uh, like schedule it, but if you wanted to run it manually, you have a button over there to just go ahead and start that automation runbook. So click on start, and once it is completed, I'll go ahead and execute the same queries to search for my index fragmentation. And you can see that like when I run, the indexes were rebuilt, which will automatically also update the stats. And if you see the fragmentation, it's like 0%. And when you see like when was my statistics lastly updated, you can see the statistics ID, and as your as your indexes are rebuilt, your stats will also be updated. So if you see the details, they are updated as well. So that's about like how to create an automation job. But let's now talk about a little bit about the query store. If you're not familiar with the query store feature before, so query store feature got introduced in SQL Server 2016 and it is there since 2016 and 2016 plus. So since then they have been adding more features into this query store. So basically query store feature is not the server level feature, it's the database level feature. Like if you want to enable the query store, you need to manually go ahead and go to the properties of the database and enable query store. Now, what does this query store do for us? Once you enable the query store on the database, it will go ahead and start collecting your query information. Like for example, what is a CPU memory IO um, IOK, like what are the capacities that are used for my query, and what is the execution plan, and all the execution stats information is stored is stored in the database. Because you enable the query store in the database, it will allocate certain storage for the query store. You can make those settings. What queries can be captured, you can choose that. But once you enable, it will go ahead and continuously capture that information. It's like a one-stop shop for your queries. You can see the how your queries are getting executed, what execution plans are being used, and as it will collect the execution plans over time, you can go ahead and see like if there is any change in the execution plan, you can see like why is my execution plan changed and did it change for the better or for the worse. If you feel that execution plan that is being used currently is worse than before, and if you think like the previous execution plan is working better than the current one, you can go ahead and manually force that last good plan so that the next time your query runs, no matter what parameter it uses, especially the store procedures, because they use the parameters, it will go ahead and force the plan that you forced. But this is an advantage. This is a wonderful advantage because if you do not have query store feature, then you can't do anything. You do not have any um, uh, you do not have any control over how your queries gets executed. I mean, of course, we cannot think intelligently like the optimizer, but then in certain scenarios, optimizer might choose a different plan based upon all the resources are allocated. Like we discussed, the statistics and indexes. If you have a stale statistics, if the job failed, like your index optimization job failed, and that actually didn't trigger the statistics to be updated, then what can the optimizer do? It can go ahead and choose the non-optimal plan, which will affect your query execution time. And in that case, what you can do is you can do a lot of things, right? You can go ahead and fix your query. Like if your query is not written properly, you can go ahead and fix it. You can go ahead and update your stats. But what if you are not supposed, like what if in many scenarios your vendor, like your client won't be willing you to make any changes to your query? In that in that case, you can go ahead and take the advantage of query store to force the last good plan. Because you have the collection of the execution plan since long time, you can see what is the history of the query execution and what is working, right? You can also compare the execution plans side by side to see which query execution plan is working fine. So that's one of the advantage of query store. But once you force the plan, let's say, it's not like you force a plan and you're done. You need to continuously monitor if your plan is changing, because once you force a plan doesn't necessarily means that it always go ahead and um, constantly use that only plan. For some reason, if if there is an update in stats, uh, the or if you like if you for some reason, like if you update the stats, if you rebuild the indexes, um, uh, optimizer has to force a new execution plan, and if that is not similar to the one that you force, then it might choose a different one without you even knowing. You might be thinking, hey, I forced a plan, and now it might be using the same. But then there might be the failures within the query store, which doesn't mean that your query is failing. All it is doing is choosing a different execution plan, but your query itself will never fail because that is a background thing that is happening just to show you the queries. But your queries will run fine, but it might trigger the differences of like how much time it is taking because you do not know it has chosen a different plan. So there are a lot of factors. So what if you want to use the query store but do not want to deal with all of this thing, right? You have like if you are a DBA like me, or if you are a developer, you have a lot more stuff to do. Like you need to take care of the other queries, rewriting the other queries. So if you want to take the advantage of query store but doesn't want to deal with like watching out for the um, plans if they are being used or not, then we are going to go to the next level, which is known as automatic plan correction. So automatic plan correction is like an advancement in query store. So as you see the name, automatic plan correction, meaning like it will automatically correct the plan for you. You do not have to worry about like looking at the forced plan, whether it is still being used or whether it has created a new plan. You do not have to worry about that. Once you are using SQL Server 2017 and above, and if you are using the enterprise edition, like if you are using developer and standard, you do not have this feature, automatic plan correction. If you are this is for enterprise only as well as for Azure. If you are in Azure, automatic plan correction is automatically enabled. So what does the automatic plan correction does is it will go ahead and continuously monitor your queries, how they are executing, what are those execution plans, and if it finds one plan is working optimally, it will directly go ahead and force the plan. And once it forces the plan, it doesn't stop there. It is like a robot. It will continuously monitor the regression between the execution plans, the changes between the execution plan, whether the last forced plan is good or the newly generated plan is good, based upon the resources and the time that it took to execute the query. It will go ahead and make the modification. It will go ahead and unforce the plan and force the new good plan. But if it didn't find the change, or if it finds the new plan was working worstly, then it will go ahead and continuously put that last good plan in place. It won't make any modification. So it works as a robot behind the scenes. You do not have to worry about forcing and unforcing the plans. Now let's go ahead and see how this will actually work in demo. Are you able to see my management studio? If somebody can confirm.
Yeah, yeah, we can see
Awesome.
it.
Awesome. So in this demo, I'm using Azure SQL database, which is AdventureWorks in my demo. And um, so as I said, like automatic plan correction, which is also known as automatic tuning. Automatic plan correction is a part of automatic tuning in Azure. Automatic tuning also contains the automatic tuning of indexes as well. So how to make sure this plan is like automatic tuning is turned on? Let's go ahead and do that through tsql. Set automatic tune, like alter database name, set automatic tuning, and we are especially looking for the automatic plan correction, which is like force last good plan is always turned on, and I'm executing that. Again, remember in Azure, this is enabled by automatically. This is automatically enabled by default, but I just want to show you how to do it through tsql. Now let's go ahead and see the automatic tuning options. What are the options and what did we choose? sorry, where am I connected? I'm connected to the local server. If you see here, I'm not connected to Azure. So let me connect to the Azure SQL database. Let me do that one more time. Alter database, database name, set automatic tuning. And then I would like to see what are my database automatic tuning options. Why is it not showing? Because I'm not running in the database, AdventureWorks database. So if you see here, automatic plan, like force last good plan is turned on. And as I told you, automatic tuning also contains the other features like create index, drop index, maintaining index. You can automate these as well. But currently we are seeing the force last good plan, which is turned on. Now let me create a store procedure, a very simple store procedure. If you see here, all it is doing is retrieving couple of columns, and it is searching on the product ID with the product ID as a parameter. So let me go ahead and execute that. And here, if you see, this is the database, right? So I have actually turned on, like this is a Azure SQL database. So or like query store is automatically turned on in Azure SQL database. So how do we see that in Management Studio? So open up the database. There is a query store folder. Once you enable the query store on the database, if it is on-prem, but if it is in Azure, it is automatically there. So you can expand that and see all of these like overall resource consumption, top resource consuming queries, and all. So let me go ahead and see, like right click and see view top resource consuming queries, just to show you like how it will look like. Like here you have like bar graphs, charts, and if you hover your mouse onto that, one of the bar chart, you can see like the query is showing in the parameterized view. If you see, but if you want to see the queries itself, you can go ahead and click on um, in the grid format. If you click on the grid format, you can see the query ID, object ID, and the query text in the parameterized view. And if you see here, whatever queries are running, it will go ahead and capture the execution plans for those. This dot represents the execution plan, but then that is, it will have its own ID. If it has the execution plan, it will have its own plan ID for that particular query ID. And if you hover your mouse over there, it will show you the plan ID, execution stats information, total duration. There is a lot more content you can observe. Like you can check the metrics over here. What all metrics you can see. What is the CPU time? If you click on that, it will, and you hover your mouse, it will show you the what is the CPU time. So based upon all the metrics you can see, that's how it will show you the execution plan. But if you have like couple of execution plans, you can also compare those plans. I will show you that. So we have actually created the simple store procedure. Now let me go ahead and clear out my query store. Now we have one of the plan ID here, right? Now I would like to clear out my store procedure by altering the database, set query store clear, and execute it. Now if you go here and refresh, it will totally delete all the data within the query store. So you need to be careful to do not run this in production. So now I would like to go ahead and also clear out my cache, because I am doing my demo, trying to show you like how the automatic plan correction works. And I would like to make sure nothing is in there in my procedure cache, because if the execution plan is stored in the procedure cache, like in the memory, these procedures, like whatever queries you run and whatever execution plans are being stored, those are stored in the memory in the procedure cache. So if as they are stored in the memory in the procedure cache, the next time the store procedure runs, it will go ahead and capture the same execution plan. So I do not want that. I want automatic plan correction to work. So just for my demo and like clearing out my cache here, but you do not have to do any of these. Like do not touch the procedure cache in production until you intended to do so. So here I'm executing, so I'm causing the workload here. It is not like one time you run the query, like store procedure, it will go ahead and automatically force. There is some certain workload that needs to be done behind the scenes for this automatic plan correction robot to work properly, because it have to analyze the number of runs. There is this internal algorithm that it have to hit. So I'm trying to create the workload here. I'm running the store procedure for 50 times. Now let's go ahead and enable the execution plan here. If you see, I'm including the actual execution plan and executing it. Now I got the results. Query is still running and execution plans are still running. Now it is using the nested loop and index seek and the key lookup. All right, it is still executing because each of the execution is giving around like 385 rows. If you see bottom of the screen right side, each execution 385 rows. Okay, our query is done. Now if you go to the query store, right, and then refresh, you see a big blue color ball. Now why the size differs, right? Like how many times you are running the query, the size of the ball, like the size of the circle will increase. And it got the plan ID 1. And if you can see the plan here, index C, key lookup, it is using the nested loop. All right. Now let's go ahead and clear out my cache again. And then now let's create the regression. Now in the previous execution, you have seen only 385 rows, right? But now if you see, I'm using a different parameter. The parameter that got 385 rows is 942, but there is a lot more skew in my data within the database. So for this parameter 707, I have like I get a lot more records. So I'm causing the regression, a lot of difference between two of the executions, right? Now let's go ahead and execute that and see the results. So the first execution, like it's still running. It is running. We are running it for the 10 times, causing the regression. Now, if you see the execution plan, it is totally different. Clustered index scan. So how many records did we get? If you see bottom of the screen, 237,000 rows, which is like a huge difference, right? So if you see the execution plan, it has done the clustered index scan. And if you see the stats here, why did it choose the clustered index scan? It thought it is better to scan all the index to grab those many records. All right. So we have seen two execution plans for the same exact store procedure with different parameters. Now let me go ahead and refresh. Now, did you observe? There is only one query that we executed, one store procedure, and that store procedure have just one query ID. But then if you see the same execution with two different parameters got two different execution plans, and there is a little tick mark over here, which represents that plan is currently being forced. I did not make any changes to force the plan, right? The robot, like the automatic plan correction, has automatically jumped in. It compared the regression between two of the plans, and then it automatically forced the plan ID 1. Now, if you see why it has actually chosen the plan ID 1, the plan ID, the query that has run for the first time for that 385 records, it has executed for 50 times. And the second execution, which have given us like 283,000 rows, it executed only for 10 times. So it have to hit certain limit to make the decision. So it has to actually hit certain CPU threshold as well. So it has actually decided. But if you'd like to see what is the difference between two of the execution plans, hold your shift key button and then click on these two plan IDs, plan ID 1 and plan ID 2, and go ahead and click on this compare. Compare the plans for selected query on the top right side. Once you click on that, it will go ahead and show you both of the execution plans side by side and what are all the other stats information available. What is like CPU, and then what is the cached plan size and parameter list and all the other details. But it has chosen to go with index seek and key lookup because that is optimal to do. You do not have to scan the entire indexes to get 385 rows. So it has actually forced that. Now, let me go ahead and see like what, but we might be having questions like, as it is automatically tuning your, automatically forcing the plan for you, you might be wanting to know why it has actually decided to go with that plan ID 1 and why not plan ID 2. So you can go ahead and uh, run this particular query, select star from sysdmdb tuning recommendations, and if you execute that, right? So this particular store procedure, like this particular system view, you can execute even though you do not have automatic plan correction. It will still show you the tuning recommendations, and you can see like all the details here, why it has actually forced that plan. The average query CPU time has changed from 2.37 milliseconds to 767 milliseconds. So it has reached certain threshold. We do not know the exact threshold it have to reach, but it have given you the detail of why it has changed. So it has changed a lot. So that's why it has actually taken that step of forcing the plan ID 1. But if you drag your mouse over here, it will provide you the details. Now, if you copy over the details and if you paste it here, right, it has given like, if you drag it here, you can also go ahead and execute this particular store procedure. So this is actually a query store procedure. Execute sp query store force plan. You need to give the query ID, which is query ID 3. If you see here, it's a query ID 3 and you want to force the plan ID 1. So all you're doing is providing the query ID and plan ID 1. So if you do not have the automatic plan correction, it still recommends you can just copy this execution. You can copy this store procedure and execute it to yourself. But if you're using automatic plan correction, it will automatically do that for you, but it will also show what it executed through these details. Now that's how the automatic plan correction works. Now let me show you how to use the query hints, query store hints. So again, in this particular this demo file, we are using AdventureWorks again, and we are using Azure SQL database again. But here I would like to go ahead and drop the store procedure and recreate it, the same exact store procedure in the database. And I should connect to the Azure SQL database. Sorry, I should connect to the Azure SQL database. All right, now I'm executing it in the AdventureWorks database. So we have recreated. Now I will clear out the cache and the query store one more time. All right. Now the same exact store procedure. Let's say like you have seen the previous demo. For one parameter, we got 385 records, and the other parameter, we got like some thousands of records, right? So it's a parameter sensitive thing. Like some parameters get more data, some parameters get less data, which is like a parameter sensitive issue. Like parameter sniffing is going on here. So let's go ahead and execute. the similar kind of pattern here with the same exact store procedure and enable the actual execution plan on here and then execute it. If you see the first execution, it has 360,000 records, and second execution is just 385 records. Now, how does the execution plan shows? Because it because we executed the store procedure for the first time. Do you remember we dropped and recreated the store procedure? And then we executed um, with this particular parameter for the first time with the 870 parameter. It went ahead and did the clustered index scan, which is like a big operation because that index is huge. And, and it is sensible that it has chosen clustered index scan because it have to grab as much data, so much data. But then why did it actually choose clustered index scan again for 385 records? It doesn't make any sense to me. But then how does the optimizer work? Once you create the store procedure, the first time that you execute the store procedure with the parameter, that execution plan that it choose to execute, it will store that execution plan in the procedure cache in the memory. The next time you run with any parameter, no matter if it is only bringing 10 records, the query optimizer will go ahead and grab the same execution plan from the plan cache and then use that. But here, do you think it is really important and is it really necessary to do the clustered index scan? No, because we are only getting 385 records. It can easily seek the index and do some of the key lookups. Key lookups are nothing but like if it is not finding the enough records in the index, like if it has to grab the other column data and the other records, if it has to satisfy, it will go ahead and get the data from the disk. That's when the index seek happens. That is what we are looking for here, which will only take a couple of resources. But then I am not allowed to change any of the data within the store procedure. And I can't recompile. So what does the recompile meaning? Recompile meaning it will force the store procedure to go ahead and create the new execution plan for that particular execution. So if I use the query hint option recompile, I need to touch the code. But I'm not allowed to touch the code. My client is not allowing me to do so. In that case, I can take the advantage of query store hints. So query store hints is a feature within the query store. If you are using the query store feature, you can take that advantage of query store hints. So query store hints have a specially designed store procedure where you can execute by just providing the query ID as well as like what kind of query ID, like what query ID are you working on and what query hint you want to use on that query ID. That's all you need to provide. But here we need to know what is the query ID of this particular store procedure, right? So use this particular query to identify that by using the some of the text from your store procedure, right? So I'm using the query SQL text with the parameter value, and then I'm going ahead and selecting and then retrieving the query ID for that particular store procedure, which is query ID 1. All right, we got the query ID 1. And this is the store procedure that I'm talking about. SP query store set hints. Query ID is 1, and then we are using the option as recompile, right? Because we wanted to recompile so that it will go ahead and recreate the store procedure, recreate the execution plan, and then it will recreate in such a way that it will only use the required operators and not the heavily used like mostly resource consuming operators in the execution plan. Now let me go ahead and execute this one. And then let's run the same executions one more time in the store procedure. Once I hit that, like, yeah, once I execute that right now, you will see the difference here because we have actually recompiled, right? So what that store procedure will do is it will go ahead and sniff. It will go ahead and start recompiling the store procedure every time it runs. So for this particular execution, which will give us like 361,000 records, it chosen clustered index scan, which is good. But the second one, which has only given like 385 rows, it doesn't have to do that. So it has recompiled because we set a hint over there. It only grabbed like index seek and the key lookup, which is good. So that's how, like, without touching the code, right? We did not make any modifications in the code. All we did that was with the query ID, and then we just mentioned the value as recompile. Now, how do we see like what query hints are enabled on my um, in my database? Run this particular view, system view, and to see like details. Now the query ID, for the query ID 1, we are using query hint ID 1, and what hint we are using? Option recompile. That is currently active. Now what if I would like to go ahead and use some other query hint? What if I wanted to force the query, like the store procedure, to use only max top 1, right? So I have given the query ID again and the option max top 1. Now I will go ahead and execute that. And now if you go ahead and see the current status of all the query hints that I have, it will only show you the updated one. It will say this particular query ID 1 is currently running query hint ID 2 and it is currently using max top 1. Now where is the query hint ID 1 go? I can't capture, like SQL Server doesn't capture the history of the information. But there is a way that you can capture it by using the extended events um, within the SQL Server. You can use the extended events to capture the history of the query hints. Now I'm going to, so max of 1 is currently being active, right? I'll go ahead and clear out my cache. Again, procedure cache, and run the same store procedures again and see our execution plans. And then how do you see like max of 1 is active? Right click on select, go to properties. And then here, if you see, the option max stop is set to 1, right? So that's how without changing the code you can do that. But what if I want to use multiple options, multiple query hints at the same time? You can do that by giving the option recompile and max stop 1 with a comma separation. You can do that. Let me do that. And then let me go ahead and clear out my cache and then execute the same store procedure with the same parameters again to see if both of will get active this time. Yes, it does. First one, clustered index scan for that large amount of data. And second, index seek and key lookup for the couple of data. And then do the right click properties, go to properties, the max stop is still set to 1. So currently both of them are active, which is good. Now, if you see, like, if you want to remove certain hints for your queries, all you have to do is like give the store procedure, execute store procedure, query store, SP query store, clear hints, and provide the query ID 1. I'm going to remove that and then see my active query hints here. You won't find any because all of the information is gone. But if you do the extended events, if you capture that through extended events, you'll have the history of the information. Now, to know how many query hints you can use by using the query store, you can go to this link here. Now, let me go ahead and share you my slides again. So that's all about the automatic plan correction. It's a wonderful feature. It is like an optimizing your queries. So take the advantage of this option. The next one is like we'll go through an overview of like automatic tuning of the indexes, right? That is one of the intelligent performance feature as well. So in Azure, I have like AdventureWorks database, which is an Azure SQL database. Once you click on the database, left side of your screen, if you see like um, this is like this is under the intelligent performance. So Once you open that up, it will show you like the create index recommendations as well. Like for example, I have seen the notification number 3 here, 3 notification. Now it shows like create index is being shown. Now let me go ahead and click on that one to see what are the details. So under the performance overview, under the intelligent performance again within the database, as I clicked on the create index option, it provides the recommendation here. Like it is showing create index and the intensity is high here. So let me go ahead and click on that recommendation to see more details into it. So it is saying like create index is actually creating a big impact if you can go ahead and create this index on that particular table. And you can actually automate this by on the top of it, on the top of the screen, you see automate. You can go ahead and automate it, but it has given you all the details, right? Once you click on that, create index action, it will actually provide you entire details of the index. Like when was like um, it will show you the index name, index type, which is non-clustered index, schema, table name, and all of that. You can just go ahead and click on automate to automatically create it. Or if you do not want to do it, you can just view the details of the recommendation. Now let's talk a little bit about query performance insight. So query performance insight is again it's underneath the Azure SQL database, underneath the intelligent performance. You have like query performance insight. So it is like a centralized location where it will show you the queries that you have executed and what are the capacities, what are the capacities that are used, like what is the CPU resources, data, IO resources, and how much time it took. And if the query runs pretty quick or it took a lot of time, it will show you here with the query ID. You can click on that query ID to look into more details. Like for example, I have clicked on query ID 61, which is first one. It will show you what is a query and how much of resources it has taken. It is like a monitoring tool where you can see how your queries are running. It's like a centralized location. And I think in the intelligent performance, we have mostly focused today on like tools that you can use to take the advantage of improving the performance of your queries in Azure. And I hope you all got some information from this session. And if you have any questions regarding this session later or now, you can contact me later on Twitter or like on LinkedIn. But if you would like to ask me now, you can ask me as well. Thank you.
Well, thank you. Are there any questions? We are pretty out of time, but if you have maybe 1 or 2 questions, then if not, then I'll say thank you very much for this, Deepthi, and also for the short notice. It was a pretty short notice that you got.
Yeah, no problem at all. I mean, I hope we all got some information and this session was useful for you.
Yeah, it was very, very, very useful. Yeah, I don't think there are any questions, so I will say thank you very much, and hopefully we will hear from you again.
Yeah, sure. Sure. Maybe I'll contact you later with my new sessions.
Yeah, that would be great. So
Yep.
have a nice weekend and
Thank you, Gisli.
bye. Yeah, thank you.
Bye. Have a
Bye-bye.
great weekend, everyone. Bye bye.